Hi, let's talk about determinants. Now, specifically, in order to talk about determinants, we need to start by talking about matrices, because you can take a determinant of a matrix. That's what you take a determinant of. So what's a matrix? A matrix is just an array of numbers. So we denote it using square brackets, and it can have however many numbers you want: 3, 4, 7, negative 13, 2, 1, 6, 11. That's a matrix. It has 2 rows and 4 columns. I could have another matrix, perhaps, that has a different number of rows and columns. Maybe I could have a really small matrix. This is a matrix that just has 1 row and 1 column. Here's a matrix that has 3, 4, 2, negative pi. This matrix has 2 rows and 2 columns. So that's a matrix. Now that we know what a matrix is, we can take a determinant of a square matrix. Now, a square matrix, that's something that has the same number of rows and columns, like this 2 by 2 matrix. So note, we can take a determinant of a square n by n, same number of rows, same number of columns, matrix. Now, I'm not getting into in this video, why would I want to take a determinant? There's lots of reasons for taking a determinant, but I don't want to get into those here. If you want to see most of those reasons, go take a linear algebra class. They have several uses for determinants. If you want to learn a unique use for that, in calculus, in multivariable calculus, there's a unique use for determinants in calculating cross products. But we don't want to get into that here. We just want to take a determinant, and here's how we do it. So first of all, the notation. If I wanted to take the determinant of a square matrix, I could say, hey, let's take the determinant of 2, 1, 3, 5. We'll take the determinant of this matrix. But that's a really cumbersome notation. So here's the notation we want to use: 2, 1, 3, 5. With these vertical lines, not the square brackets that mean a matrix. We're just going to get rid of those and just use vertical lines. It's a quick and easy thing to do, and that's going to come in handy for us because, again, we might be taking a lot of determinants, and I want to be able to write things quickly and easily. So, for a 2 by 2 matrix, and again, that is square, here's how you take the determinant. The determinant of A, B, C, D equals, and what we're going to do is we're going to multiply along the diagonal. So I'm going to take this diagonal first. This is AD. And then I'm going to subtract what's on the other diagonal. So in this case, that other diagonal has this BC, so I'm going to do AD minus BC. So let's do a quick example of this so we can try this out, our new determinant taking skills. So if we do an example here, maybe we want to take the determinant of the matrix 3, 2, 5, 10. If we do that, first of all, there's the notation: 3, 5, 2, 10. Everything goes in the same place. 3 times 10 is 30, minus 2 times 5 is 10. This determinant equals 20. If we would like to take the determinant of 1, 6, negative 3, 14, we're going to have 1 times 14 is 14. And then 6 times negative 3, that's 18. So we're subtracting negative 18. That means we're effectively adding 18 here, so that we get a total of 32. That's our determinant here. And again, I have not given you any meaning for determinants. I'm just saying we could take this determinant. So now let's take a look at the determinant of a 3 by 3 matrix. And to find the determinant of a 3 by 3 matrix, what we're going to do is, first of all, we need some signs, and I'm just going to write this up here, and it's not going to make any sense just yet, but it will in just a moment. So I start with a positive sign in the upper left, and because it's a 3 by 3 matrix, I just go every other one, positive, negative, positive, negative, positive, negative. There we go. So here's how we take this determinant. Choose one row or column of the matrix. Okay, I'm just going to choose one row or column. You can choose any row, any column. And what we're going to do is we're going to take each element of this row or the column, multiply it by the sign from the diagram above, and by the determinant of its minor. Okay, what's a minor? What's a minor? A minor says if I look at a particular element of a matrix, maybe I've got the matrix A, B, C, D, F, G, H, J, K. If this is my matrix and I wanted to look at element D, then the minor says just ignore the entire row and column that are there. So the minor of D is going to have us looking at B, C, J, K. So that's how we do a minor. So let's do an example, and hopefully this will help you in the future. So we're going to start with matrix. We're going to take the determinant of 3, 1, 7, 2, 4, 3, 1, negative 5, 0. Okay, I have a choice. I can choose any row or column to work with. Looking at this, I think I want to choose a row or a column that includes that last 0. Why? Because it's nice to multiply with things by 0. It's going to make life easier for us. So I'm going to choose a column or a row that includes that. So I'm probably going to choose either the third row or the third column. I think I'm going to go with the third row in this case. So looking at our diagram from before, we know it's positive, negative, positive, negative, positive, negative, positive, negative, positive. So that means we're going to be starting with a positive term. This will be positive 7 times the determinant of its minor. And the minor of 7, if I wanted to find the minor of 7, what I would do, looking at 7, I would cross out this row and this column. And so we would just be looking at 2, 1, 4, negative 5. All right. The next thing we're going to do, that next term, that's a 3. Now that's going to be a negative because it's coming from that second position, so minus 3. And now we need to look at the determinant of its minor. So its minor, if I look at this 3 and I cross out the row and the column that it's in, then we're actually looking at 3, 1 is that first column, and 1, negative 5 is that last column. All right, and then we're going to have plus, because it's that third position, that's a plus 0 times its minor. And I don't really need to write down the minor here because it's going to be multiplied by 0. But just in case I want to get a little extra practice with that, that's going to be 3, 2, 1, 4. Now again, I chose this strategically so that that last term is just going to go away because it's 0 times something. So the first one we have 7 times 2 times negative 5 is negative 10 minus 4. Minus 3 times negative 5 is negative 15. Minus 1 times 1 is 1. So we have 7 times negative 14 minus 3 times negative 16. And I'm going to admit that I use a calculator to do multiplication like this because I don't multiply things like this in my head. Math isn't done in your head. Being able to do arithmetic in your head is a nice skill, but it's not what math is about. Also, I do want to mention, I've got a negative times a negative. That's why that becomes addition. So we have negative 98 plus 48. That looks like negative 50. And that's the determinant of this 3 by 3 matrix. Now you might be wondering, because I said earlier we can take a determinant of a square matrix. What if we had a 4 by 4 matrix? Could we take a determinant of a 4 by 4 matrix? Yes, and you would do it exactly the same way. You can expand this little diagram to have another row and another column. And now you can take the determinant of a 4 by 4 matrix, but it becomes much harder because for the 3 by 3 matrix, we wound up taking 3 2 by 2 determinants. For the 4 by 4 matrix, you'll wind up taking 4 3 by 3 determinants, and each one of those involves 3 2 by 2 determinants. And so we're really taking a whole bunch of determinants. And the more rows and columns you have in your square matrix, the more 2 by 2 determinants you eventually take, and the more steps it takes to get to those 2 by 2 determinants. Well, that's it. The one last thing I would encourage you with is remember any row or column should give you the same result. So if you are concerned about making mistakes, you can always try to take the determinant 2 different ways for the same problem. So let's actually try that here. We had 3, 2, 1. 1, 4, negative 5. And then we had 7, 3, 0. And I'll tell you right now, a lot of people I know that aren't comfortable with determinants, they take the determinant the same way every time. They just use the first row. Okay, so let's try this with the first row this time. No reason whatsoever to use the first row. We're just going to use the first row. So that would be 3, because that first one is positive. The minor there is 4, negative 5, 3, 0. And I'm not going to color code it this time because I'm hoping we're getting more comfortable with this. The next one is negative, because that's coming out of that diagram, positive, negative, positive. 2, and that determinant 1, negative 5, 7, 0. And finally plus 1, and that determinant is 1, 4, 7, 3. Now again, this is harder than the way I did it the first time because none of these are just going to cancel out. We're going to have to calculate each determinant. That's going to be 4 times 0, that's 0, minus negative 15. That's going to be a positive 15 in there. Minus 2, there's another 0. Plus 35, okay, plus 1, and that's going to be 3 minus 28. So we have 3 times 15 minus 2 times 35, 3 minus 28, plus negative 25. So that is 45 minus 70 minus 25. Sure enough, it's negative 50. If you'd like to know why determinants can work on anything, please take a linear algebra class. This is a really cool thing that you can do this using any row or column. And again, if you want to look for applications of these, please mostly take a look at linear algebra. But again, there's one calculus application that I'm aware of offhand. That's it for now. I'll see you in the next video.